Let's take a look at another critical component, the connector. Over the years, connectors have evolved just like cable. Since we're pushing more signal down the cable than anyone else, we need to make sure nothing in that line restricts that flow. We can't use crimp connectors. They apply pressure on 6 points on the cable to make a solid connection. In each of these 6 pressure points, the cable is compressed, which impacts the connector in 2 negative ways. First, it changes the shape of the round cable, which again changes the impedance. Secondly, each of the corners of the crimp create a path for water migration into the connector. For these reasons, we require only compression connectors be used on DirecTV installations. The compression connector applies equal pressure all the way around the cable and makes a good solid seal, preventing moisture from getting in the back of the connector. Still, no matter how good a connector you use, the most important consideration to longevity is how it was cut on the cable and how you protect it from the elements. Far too many service calls result from connectors that just aren't put on correctly or weather sealed. The weakest point in any electrical system is always the connections. It's critical that they each be done correctly. Though each of you should have been shown how to cut on a connector when you were first hired, let's review it again. The first step is making sure you have the right tools to do the job. That means you need a quality prep tool and the right compression tool for the connectors you're using. Because there are dozens of connector manufacturers and many have their own specifications, you need to make sure the compression tool is the right tool for the connector you're using. For this demonstration, we'll be using a PPC DirecTV approved connector with a VT200 compression tool PPC recommends. The prep tool we'll be using is a Cable Prep CPT 6590, also recommended by PPC. This tool has a replaceable blade cartridge, RBC 6590. You can tell when the blades get dull and need replacement. The first sign of worn blades is when it takes more than 3 revolutions to cut through the braid. As the blades get worse, the stripper will not cut away the braid evenly, leaving long pieces like this that protrude beyond the base of the connector. All cable prep tools have 2 blades. One cuts back the jacket, and the other cuts back the braid, foil, and dielectric. It's critical these blades be sharp and properly adjusted. Blades are inexpensive. You should always have a spare set on your truck to make sure the connectors you're cutting are done right. The blade that cuts back the braid, foil, and dielectric has a notch here. This notch prevents the cable prep tool from scoring the center conductor. Scoring the center conductor has a dramatic impact on signal flow and weakens the center conductor. If scored, it can break off in the connection, so this notch serves a very important purpose. Let's take a look at how these all work together. The cable is inserted into the prep tool with the end going in the direction of the arrow. You simply close the jaws of the tool, then rotate it about 3 full turns. You'll feel the braid cutting. Open the jaws and lift out the cable. Now pull the jacket, the braid, foil, and dielectric off by hand. I've seen a lot of technicians just pull off the cutaway sections using the tool. Well, that shortens the blade life, so I recommend you remove the material by hand. Inspect the center conductor for any dielectric residue. If you see any, carefully scrape it off the center conductor, taking care not to damage it. I usually scrape it off with my fingernail. That won't damage the center conductor like a knife or other sharp object. Now fold back the braid and inspect the foil to make sure it's clean cut and there are no shreds across the dielectric. That's how it should be done. At this point, you're ready to put on the connector. Slip the connector onto the cable, pushing it in until it stops. Look inside, make sure the dielectric is flush with the bottom face of the connector. Now, place the connector center conductor into the hole in the compression tool and seat the back of the connector against the stop. Squeeze the tool closed until it stops. Release the handle of the tool and slip out the connector. Now give the connector a pull test. Check to make sure you have about 1/8 of an inch of center conductor extending beyond the connector. If you have more than that, trim off the excess using side cuts.